Hello, can people in the chat hear me? We'll wait for some more people, but I'm hoping the audio is working. Oh, hi, the goat. Hi, Bella, as well. Okay, yeah, it's working. Gosh, how honoured we are to have the goat in the chat today. How are you all doing? How Bella as well? Nice to see you. You've been here a couple weeks in a row. Hi, Olivia as well. How is everyone doing? We'll wait a little bit for people to join. Oh, how am I doing? Yeah, I'm doing well. It's been quite cold the last week, but um, it's been it's been nicer today. I think it's been a bit of sun today. How is all of your schoolwork going? What hobbies are you doing outside of school? Yeah, how are you finding the course as well? Oh, I've got someone watching from Zambia. That's very exciting. Are you doing a UK syllabus, Daniel, or are you just sort of, does this align with what syllabus you're doing over there? Yeah, it's not too cold today. Yeah. I much prefer it when it's not freezing. I'm not very good in the cold. I'm not very good in the heat either. I'm quite like fussy with temperature, I guess. Yeah, Daniel, is it a UK syllabus you're doing from like an international one you're doing over there? So I've switched around what topic we're doing today. We were going to be doing sectors and arcs, but I realised we actually have done quite a lot on circles. And I know someone had mentioned before that histograms was something that you'd find quite useful. So I thought we'd switch it up and instead we'll do histograms today. Hello. Yeah, we usually start around like 5 past-ish. I've just got some exam questions on histograms from different syllabuses, different styles of questions that you can come across, and we're just gonna go through pretty much everything you need to know for GCSE, and it will cover any of the syllabuses. So yeah, that is the plan for today. How do people feel about like histograms and generally these sort of tables and putting things into graphs? You're good with them, Bella? Okay, good. Hopefully you'll be able to sort of help everyone along and answer some of the questions as we go then. I think like I haven't got ones on the things like cumulative frequency today, but I think the thing that makes it more confusing is that you have all these different types of graphs as well. Good afternoon, Mikhail. Hope you're doing well. Nice to see you today. Yeah. So I think the thing that like people can often find confusing is you have to remember all these different types of ones like frequency polygons, histograms, cumulative frequency, and also just normal graph plots, so just normal frequency graphs. Watching in high school. Ah, nice. I guess high school, so in the UK, that would be like our secondary school, I guess. Yeah. It's very exciting that we have some people from outside the UK watching. It's very, very cool. So I think what we'll do is we'll just get started, I think. So before we look at the questions, just a general question about histograms, and anyone can answer in the chat. It was really great if people can get involved in the chat. So what is with histograms? How do you read off a frequency from a histogram? Because it's not like a normal graph where you just read it off the y-axis. How do you figure out what the number of events are or the frequency of things are in a histogram? Does anyone know? Good afternoon, Kofi. Is this channel good for a person in secondary school? Yep. Yeah, we're doing GCSE level here. By seeing where the end of the bar ends. Yeah, that is part of it. What I was looking for, which might be what you're getting at, Mikhail, is the area. So histograms are really all about areas. And if you want to figure out the frequency of an event from a histogram, you have to work out the area, and usually we have rectangles there, so it's usually the area of a rectangle. However, you are partly right, Mikhail, because they're usually rectangles, that means the area is the width of the bar, which is how far along the x-axis it's gone, times the height, which is how far up the y-axis it's gone. So we call the height of it a frequency density. And that's often what we want to start by working out if we have a table including frequencies. Because if we want to read the height of, we can no longer just say that's the number of whatever the events are. Instead, we need to use that and convert it into an area. So all today, when your brains sort of tune in to with histograms about areas, and then you'll be sorted really. So what we do is we just have a look at some of these exam questions. Can you all see that, or is that a little bit small? Let me know if it is a bit small. I am going to zoom in on my computer. It is a bit small, but I want you to see the whole question. So I'm going to zoom in because I'm a little bit on the blind side. So it is a bit small. Okay, good. I guess it depends on what you're watching YouTube on, actually. Maybe it's not the best question. So I'm hoping this is a good size for everyone. Okay, so here is some information about the ages of babies at a clinic, and then they want us to draw a histogram to represent the information. So when we're going to draw a histogram, we need to first figure out where the bars are going to lie on the x-axis and then where it's going to lie on the y-axis. And they're all going to be rectangles. So we're going to use what we were saying before. So the frequency over here will be the area under the rectangle we're going to draw. So, oh gosh, sorry. As everyone knows, I'm not the best with technology. I haven't figured out how to turn all the notifications off. So, okay, so our age, and we've got some widths for these. So 0 to 5. And that's going to be the width of our rectangle. So our rectangle at the bottom is going to go from 0 to 5 on the x-axis, which means our area is going to be 5 minus 0, so just 5, times whatever is on the y-axis. So we don't have any values for a y-axis yet, so that's really what we got to figure out before we can draw the histogram. And we're going to call that a frequency density, and I'm going to put that in the table over here. And then over here, I'm going to call this the class width, which is just how wide my bar is on the x-axis. So if anyone wants to put in the chat, what will the class width be for the first line, or for the first row in this table? So for the 0 to 5, or x between 0 and 5, what will the class width be? Does anyone know? $18. So 18 is our frequency, so that's actually going to be the area. So what we're going to do here in the frequency density, we're going to take our area and we're going to divide it by the width. So our rectangle is going to have an area of base times height. The base is going to be the width on the x-axis, and the height is going to be how far up the y-axis we go. And it'll be a bit clearer, I guess, when we go to draw it out. So we need to first figure out the width of the bar along the x-axis, which is just going to be how wide the group is over here. So for the first one, it's just going to be 5 minus 0, because that's how wide that interval is. And then the frequency density here is going to be 18 divided by 5. If you put that in your calculator, that should give you 3.6. So this is where we're going to start. We're going to do this for every single row in this table. So the next one, we have 5 to 10, which means the width of that group is going to be 10 minus 5, which is also going to be 5. And then the frequency density will be the frequency, 23, divided by 5. So that should give you 4.6. So for this one, this will be 23 over 5, which is 4.6. And we just carry on. So between 10 to 20, the width of that group will be 20 minus 10, which will just be 10. And therefore the frequency density here, perfect, Bella, yeah, exactly 10. Yeah, as I'm doing it, type in chat what you're getting for this so you can compare your answers. Helps me know that you're all following. So yeah, the frequency density here will be 17 over this, which will be 1.7. Carrying on, the next class width is 20 to 50. So our width here is going to be 30, exactly, Mikhail. Brilliant. And yet, Lucy, you're completely correct. And therefore our frequency density is going to be 21 over 30, which is going to be 0.7. So I have followed you all along here. You're all very right. That's very good. 0.7, perfect. So now this frequency density is going to be our y-axis. And the idea is that times the width will give us an area, which will tell us the frequency. So now we go down to the graph paper. We try and shift everything about. And I'm going to go out a little bit. Okay, so we have this over here. I will tell you the values again. I don't think I can fit it all onto the same page. But okay, so the first group was 0 to 5. And we said that the frequency density is 3.6. A good thing to do with these questions when you're drawing graphs is just double check what each small square represents. To do that, just take the difference between any 2 points on the graph, usually the ones that are labeled. So 5 minus 4 is 1. And just divide it by how many squares are in the interval. So in this case, 10. So therefore, each square here is 0.1, which makes it a bit easier. So yeah, so 3.6 is just there going to be sitting here. Whoops. Oh no. Okay, it's going to sit here. Oh. There we go. So that's where our 3.6 is going to sit. And we're going to end our x at 5, which is going to be over here between the 0 and 10. And then in an exam, you'd use a ruler here. So ignore my squiggly lines. In an exam, do this more perfectly. But we're just going to connect these up. So this line here is going to go up to about here. And then we will connect this line up to here. So that will be our first bar. So if I was to work backwards from this to refine the frequency, to find how many have this age between 0 and 5, I would then just times width by height to get the frequency back. So we just reverse that in the table. And we just carry on from here. So our next one, it was from 5 to 10. And we found that the frequency density was 4.6. So that is going to go all the way up to here. So we can just connect our line like so. Up to there. And then our next interval was from 10 to 20, and we figured out that the frequency density was 1.7. So we just find our 1.7 on the graph, which is going to be here. And we're going to go up to 20. Draw the bar upwards from here. And then our last interval was from 20 to 50. And we stopped at 0.7. Our frequency density was 0.7, which is going to sit here. So that's going to be to there. like so. So that's what we will do for histograms. Area is now our frequency. We've already worked out frequency density is here. Is everyone happy? Is anyone not happy? I will follow it in chat. I'm going to move on to the next question. It's very similar to the next one, so let me know if anything is not making sense. So where did my mouse go? Okay, so we're going to go on to here. Happy. Good. I'm glad to hear that you're happy. All right, so now we're going to like use a histogram, but this time to work out a proportion. So this is saying to us, the histogram shows information about the numbers of minutes some people waited to be served at a post office. Work out an estimate for the proportion of these people who waited longer than 20 minutes to be served. So yeah, anyone type in chat what you think you would do here. Key thing here is this word proportion. Does anyone know how we work out a proportion of something? I'll give you a few seconds because I think there is a bit of a delay. So, a ratio, pretty much a ratio, Finn. Yeah, pretty much. It's more like a ratio of the bit we're interested in to the total, if you want to think of it like that. And we usually represent it as either a fraction or as a percentage, and it's up to you which you prefer. So what you want to do is in your fraction, on the top of the fraction is going to go the part you're interested in. And like there are 5 cats in every 6 dogs. Sort of. It would be more, in that case, the proportion of cats would be 5 out of 11, because then there'd be a total of 11 animals. So it'd be 5 and 11 are cats, 6 and 11 are dogs. So yeah, so on the top goes the bit we're interested in, and on the bottom goes the total. So in this case, the bit we're interested in are the number of people. Oops. So the number who've waited more than 20 minutes divided by the total. So that's what we've got to do. First of all, we need to work out the total probably. I think that's the easiest. Best way to do that is just find the area of each bar and add them all together. And that will tell us the total number of number of people who've been waiting. So first of all, let's do the bar on the left. We can, each square represents, I just realized this was from earlier when I was double checking the pen worked. So yeah, each square is going to represent 5 over 10, because that interval of 5 has 10 squares in it. So we know that each square here represents 0.5. So 4 squares in, that's 0.5 by 4, which is going to be 0.2. And then the height of this is just at 2.5. So therefore the total, hello economist vocabulary. So we have, for that very first bar, we have 2.5 times 0.2. Wait, am I being silly here? I am being really silly. Just 2. Oh no. 2. Okay, so 2 by 0.2.5 is going to be 5. So that's how many are in this first bar. And then we can carry on from there. 2 to 5, or 5 minus 2 is going to be the width of the triangle, of the rectangle. So it would be 3 times 4, which is going to give us 12. The next width of that rectangle is 5. And then that goes all the way up to 3.4. So that is going to give us 17. So we have a 12 here, 17 here, and we can just carry on here. So then we can say 5 is the next width of the next rectangle, and that goes all the way up to 2.2, and that's going to equal 11. And then finally we have the width of 15, and that has a height of 1, so that is just going to equal 15. So for our total, let me just scroll down so that we can all see everything. So the total of this is going to come to, and it should end up being 60, I believe, but let's just double check. So 5 plus 12 plus 17 plus 11 plus 15 is 60. Is everyone happy with this so far? Everyone following? Let me know. So that should be our total. Oh no. Continue. Okay. Fab. If anyone's not, let me know where I've lost you as well. So this is 15. So now we can say, we need to figure out what bit we're interested in. So we need to figure out how many people are waiting longer than 20 minutes. So this is where it's useful to go back to the histogram. And this is one of the reasons why we might use a histogram, because this is one of the things using a histogram that makes things a bit easier. So first of all, let's find where 20 is and just draw a line vertically upwards. So we'll go from 20 and we will go up. And they're asking for the number of people who've waited longer than 20 minutes. So that means we are looking for people who've waited for more time, so on this side of the line. And then we can just shade in that bit. So this is the area that we are interested in. It is an estimate, and notice they mention here an estimate for the proportion. The reason being is we only know there are 15 people in that interval 15 to 30. We don't know actually if they're evenly spread out between that. So we don't know if there's actually like 14 people who've waited 16 minutes and only one person who's waited like 29 minutes. Whereas if we're just finding the area in there, we're assuming that it's all evenly spaced out over that interval. So that's why we call these estimates rather than actually the real proportion. But yeah, so we can work out the area here in the same way we worked out the areas of the other rectangles. So the width of this is 10. Let's go down to here now. There you go, you should just be able to see everything. So we have 10 times, and the height of this was just 1. So 10. So therefore, 10 people out of a total of 60 have waited more than 20 minutes. So our proportion, if we go down a bit further, so our proportion is going to be 10 out of 60, and then we can simplify our fraction to 1/6. And that's your answer. Again, is everyone happy? Any questions about any of that, or shall we move on? I'm going to assume we move on. But again, if anyone is not happy, let me know. If anyone has any questions, there's a good chance that someone else will either have the same question or not have thought of it themselves. But we shall carry on. I'm glad to see people are happy. This is great. Okay. Again, I'm going to zoom in. Good. Okay. Let's carry on then. If everyone is happy. Alright, so the histogram shows information about the speed of cars as they pass a checkpoint. the scale on the frequency density axis is missing. And if we scroll down, not zoom down, try and get as much in as I can. So the histogram shows information about 480 cars. So this here, immediately I'm probably going to pull this number out and say this here is my total. And that's what my total area is going to end up being as well. How many cars does the first bar represent? Okay, does anyone have any idea how we would do this and what is making this a bit more complicated? Give you a little second to think about it. Okay, so to be able to know what the frequency of cars is in that interval, so in that first bar, we'd have to work out its area. Histogram's all about area. However, we don't know the height of the rectangle yet. We don't know what the frequency density there is, which is a problem. So what we need to do first of all is work out what one square on the y-axis represents. And a good way to do that is just pick out some of the big squares, because otherwise you're going to be writing out quite a lot. So each of these big intervals here, and just call one of these x. So if we say from 0 to that first square, that's x, then that means the next one is going to be 2x, the next one is going to be 3x, 4x, 5x, 6x, and then 7x. And now we just have x to find out. Because once we know x, we can work out the area of the first bar. So it'll become a lot simpler once we know that. There's more than one way to do this. Also a counting squares method that you might learn in school. I prefer this. I quite like algebra, so that's probably why. But there's more than one method. So if the method I show you today doesn't work, there will probably be another method that you'll prefer. Not doesn't work. If it doesn't work for you, yeah, depends how your brain works, which you prefer. But I'm going to use these x's, and I am now going to, in terms of x, write out an equation for what the total area would be. Because I know the total area should add up to 480. So I already know what that equals. I just don't know what x is. So now I'm just going to write out for each bar what an area is for this. So for the first one, I have a width of 15, so 30 minus 15. I have a height of 5x. So in total, I have an area of that first bar of 75x. Perfect, yeah, then 75. 480 being the total as well. So then the next bar, we have a width of 5, so 35 minus 30. We don't have as much space here, but I'm just going to do it here. And then we have a height of that of, so if we're saying 6 to 7 is 1, we have 5 squares in between it. Each square represents 0.2, so 6.6x. So I'm just going to double check this. So 5 times 6.6 should be 33. Yeah, it is. My brain is not in gear. I just want to double check. So 33x. Perfect. Yep, good. And then we just need to do the last bar as well. So the width of the last bar, 50 minus 35, which is 15 times. And then the height of that, we've got 4 squares up. Each square is 0.2. So we've got a height of 0.8. That is an 8, I promise you. So 15 by 0.8 is 12. Good. Oh, 12x as well. So now what we have, what the area of each of these square rectangles represents in terms of x. So to find the total area, which is what that 480 equals, we just add them all together. So we have 75x, 33x, and 12x. Oh, I just realised I'm going off the screen. I'll rewrite that. Okay, 120x, you are exactly right, Mikhail. So this all adds up to 120x. And we know that that equals 480. And now it's just a little bit of algebra. We just have to rearrange this in time to find what x equals. So x is going to be 480 divided by 120, because you need to bring this over here. So x is going to be 4. Finn, have a double check of your working here as well. So yeah, 480 over 12, over 120 will give you 4. Oh, I see, actually, I understand where your answer is from now. Sorry, Finn, you are not wrong. So we are then gonna go back to our equation for that first bar. So for the first bar, the area, which is going to equal the number of cars, we said that was 75x. We know what x is, that's 75 times 4, which is then 300. So Finn, very well done for getting that. And there's your answer for part A. For anyone who's interested in part B2, you would do this in the same way as the question before. I'm a bit conscious of making the diagram look even busier, but I'm going to choose a different colour maybe. We would go for 40, go up to 40. They're saying what number are over the speed limit, so in this area here. So for part B, the number of cars over 40 will be the width, which is 10, times the height, which is 0.8x, which is just going to be 3.2, which will be 32. So 32 cars are over the speed limit of 40 miles per hour. So yeah, that is where we're going to leave it. I hope that has been useful for everyone. It seems like everyone's been following along really well, so well done. And I hope to see you all next week. Next week we're going to do a little bit on vectors. So if that's something that will be useful to you, then do come back. And I hope you all have a lovely week. Inga, my tutor, has left a little feedback link, so if there's anything you could suggest to us to improve or anything you like about the sessions, do put it on there. It's really, really helpful. Also some other sessions on chemistry, computer science, so do check those out as well. And yeah, no worries. I'm glad you found it useful. Thank you all for being here. And I'm going to say goodbye. Have a lovely week. Bye. Oh, I say that and then I can't remember where the... Oh, there it is. Bye. I'm glad to hear that, Bella.